Salam sir. Today our group BB1 section 4 would like to present our project which is hydropower plant. Before that, let me introduce my group members Rozalinda, Syarafana and myself Tan. First of all, let's see what is hydropower plant. What infrastructure is related to the fluid mechanics. Hydropower, or called as hydroelectric power plant, is typically a system with three parts. A power plant where the electricity is produced, a dam that can be opened or closed to control water flow, and a reservoir where water is stored. For the process flow, the dam creates a head or height from which water flows through a pipe from the reservoir to the turbine. Then the fast-moving water fluid is the main component to act a large water force spinning to the generator, so that's the way it produces electricity. The total power generation capacity of the hydropower plants depends on the head of water and volume of water flowing towards the water turbine. In theory of fluid mechanics, the water flowing in the fluid system possesses two types of energy. First one, the kinetic energy due to the flow of water, and the second, the potential energy due to the height of water. The formula for total power that can be generated from water in hydroelectric power plant due to its height is given by P equals H rho G. The hydraulic head is the difference in water levels between the intake and the discharge point of the installation. Water discharge is the volume of water expressed as cubic meters per second passing a point in a given amount of time. The greater the hydraulic head and rate of water flow, the greater the potential energy that can be converted to electricity.
Hi, Assalamualaikum and hi, my name is Rozalinda. So I'm your net presenter for today, and I'm going to present to you the construction process for a hydropower plant. There are only 6 primary components required to construct a hydropower plant, which are dam, pressure tunnel, suture tank, pelvis house, penstock and powerhouse. The dam is an artificial concrete barrier constructed across the way of river. The catchment area behind the dam creates a huge water reservoir. Number 2 is the pressure tunnel takes water from the dam to the well house. In the well house, there are two types of well available. The first one is main slashing valves and the second one is automatic isolating valves. The slashing valves control the water flowing to the downstream, and automatic isolating valves stop the water flow when the electrical load is suddenly turned off from the plant. Automatic isolating valves is a protecting valve, does not play any direct role control the flow of water to the turbine. It only operates during the emergency to protect the system from burst out. The penstock is a steel pipeline of suitable diameter connect between the well house and powerhouse. The water flows down from upper well house to lower powerhouse through this penstock only. In the powerhouse, there are water turbines and alternators with associated step-up transform and switchgear system to generate and then facilitate transmission of electricity. At last, we will come to the surge tank. The surge tank is also a protective accessory associated with hydroelectric power plant. It is situated just before the valve house. The height of the tank must be greater than the head of water stored in the water reservoir behind the dam.
For part of technology, the hydropower plant can be said as a mature infrastructure that can be applied with a range of technologies according to their requirements. Today, we are going to look at those hydropower plants with more specific and advanced technologies in order to meet the energy needs and the modernization needs in the future. Firstly, the pump storage power plant. The pump storage hydropower plants operate with two reservoirs, a lower and upper reservoir, which are connected to each other through tunnels. It has divided into two modes in the process of electricity generation. In production mode, the plant operates like a conventional hydroelectric plant. Water is released from the upper reservoir through the turbines to generate electricity. In pumping mode, the electrical energy from the grid is used to pump the water from the lower reservoir to the upper one. In this case, a motor generator is used to work either as a generator in the production mode or as a motor in the pumping mode. With regards to the hydraulic system, the choice is between reversible pump turbines able to work in both directions. Thus, the pump storage power plants are more mature technologies to provide the full range of grid stabilizing services with the overall efficiency in the range of 70 to 85%. Secondly, in stream technologies and offshore hydropower plants, it refers to the use of hydrokinetic turbines to harvest the energy of naturally flowing water, such as stream, tidal, or open ocean flows without impounding the water. This technology can be integrated into existing facilities like these canals or falls to generate electricity. These facilities basically function like a run-of-water scheme, but also a significant development potential exists for in-stream technologies through offshore hydropower, which is a less established but growing group of technologies that use tidal currents or the power of waves to generate electricity from seawater. Last but not least, the hybrid hydropower plants. Hybrid power plants work with one or more different types of generation as an integrated unit and can occupy a single site or comprise a microgrid. Hybrid power plants may be connected to the grid or be far from the grid in remote areas where they represent the main source of power. In hybrid power plants, hydropower can be combined with solar or wind power to increase the stability and reliability of electricity generation. The hybridization allows PV panels or wind turbines to produce energy when the sun or wind is available, while saving water for hydroelectricity to complement during intermittent times. The possible configurations for hybridization are subjected to the specific demand for energy while taking into account the raw cost and maximum use of resources.
This slide shows the issue related to construction process. First is this plant cannot be constructed anywhere according to the load centers. This is because of generally it is constructed in hilly areas to achieve heat difference of the hydroelectric power station. Second is the long transmission lines required to transmit the generated power to the load centers. This is because to develop kinetic energy to turn the turbine, due to gravity, the water need to fall from higher to lower place to produce electricity. Recommendation that can be done to improve this hydropower plant is first, develop efficient low impact energy sources for future dam related projects to lessen harmful consequences. This is because of to build this hydropower plant, it has higher effect, higher rates to the surrounding area. Second is to improve the balance of energy with biodiversity conservation and protection of human welfare. This is because of if there's no extra careful planning in building this hydropower plant, it might has effect to the biodiversity and human welfare. The conclusion of this hydropower plant is that the impact of hydropower plant has effect on the environment depends on the size of the hydropower. The bigger the size of the hydropower plant, the bigger the effect on the environment. The technology used and the numbers of additional infrastructures required in surrounding area. This is because of to build this hydropower plant, it requires such a big area to complete the construction process of this hydropower plant. It means the planning of this hydropower plant need extra careful steps to lessen the disruption to the environment and also to the habitat.